I am Murugalakshmi, Assistant Professor from the Department of AI&DS. Today we are going to discuss Unit 3, Ensemble Techniques and Unsupervised Learning. So which is one of the most powerful ideas in machine learning. You will understand why combining multiple models give better performance than relying on a single model, right? So in that ensemble learning, why we are combining a multiple model, it's give better performance than relying on a single model. And how the concept is applied in a real world system like recommendation of engineers, recommendation of engines, fraud deductions, as well as a medical diagnosis. So in that ensemble learning, so first we wanted to know what is ensemble learning, right? So ensemble learning is a techniques where we use a multiple small or a weak model instead of just one. So ensemble learning is a method where we use many small model or weak model instead of just one. So individually, each model may not give very strong on its own. Each models may not give a very high accuracy output, but when we are combining their prediction, the final results became more accurate as well as reliable, right? So for example, if you take in a real-time example, think of a panel of a doctor is there. They are diagnosing a patient. So one doctor opinion may not be perfect, but when multiple doctors discuss and give a combined decision, the diagnosis is usually more accurate. Similarly, ensemble learning it combines the decision of many models. Have you understand? So, ensemble learning is a method. We use a multiple small or weak model instead of just one only. But when we combine a number of predictions, we are getting the final results. So in that final result, it is more accurate as well as more reliable. Now we are going to see types of ensemble learning. Ensemble learning is divided into three types. The first one is bagging, second one is boosting, and the third one is stacking. So in that, today we are going to see each model differ in how the models are trained and combined. We have a three different model. In that we are going to train each model, and each model they are going to give some output is there. So in that we are going to predict the goal is the same. Okay. So it is used to improve the accuracy as well as reduce the error. In today's lecture, we will mainly focus on bagging and boosting alone. So here the slide. So in bagging, there are multiple models are trained independently. So here we have given different models. Okay. So these are the different models. Okay, different subsets. Different models are trained independently. So usually a different random subset of the training data. So after training their results, the results are combined. So by using a different model, we are going to get in each model, we are getting one output. So here one output, and in this model we are getting some output, and here also we are going to get some other output. So these three outputs are combined. Adding these three output, and we are going to get a average, and this is a final prediction. So from that average we are going to get a accurate prediction is there. Okay. So after training their results, the results are combined using a voting for classification or averaging for regression. So you all know voting and averaging. So which is a majority prediction is there, that will come under the category of voting, and from that we are going to take an average for regression. So by using these techniques, it is used for reduce variance and helps to prevent overfitting, especially in the models like decision tree. Okay. So here the base model is there, no? So in that base model, We are going to be give different types of models. So in a decision tree, random forest, or support vector machines like that, we are going to give different set of models. It is implemented in by especially in the model like a decision tree. It is helps to prevent overfitting, and also it is reduce the variance also. So it will take a real time example. So consider prediction of house price. So instead of using one decision, we train a multiple decision tree on different subset of data and average their predictions. This gives a more stable as well as accurate house price prediction also. So the next one, the model here, the model are the same. So what we are seeing in the diagram, so which is explained here. The model are trained independently on different random subset of the training data. So in the first step of bagging is a bootstrap sampling. Okay, so bootstrap sampling means it's a creating a multiple data set from the original data. Okay, it's a creating a multiple data set from the original data. The sampling is done with the replacement. The sampling is done with the replacement. The same data point can appear in multiple times. The same data points can appear in multiple times. So for example, if you imagine conducting a student feedback survey, if we are going to get a student feedback survey, so you randomly select students multiple times. So some students may be counted more than one. This helps to estimate how stable the feedback results are. So in the next step, we train a base model for each bootstrap data set. Okay. So in the next step, we need to train a base model for each bootstrap data set. So in each model is trained independently. The model can be trained in parallel. The model can train in parallel. Usually in a decision tree are used as a base learner. So training models are independently save time and add diversity, which improve overall performance. So in a real-time example, the think of multiple teams, they are solving the same problem independently. So what happened? Each team may find a slightly different solutions, but combining that ideas, it's give the best final solutions. It is a acceptable one, right? So same thing, okay, the bagging algorithm. So in that bagging algorithm, what we are going to do to train a base model for each bootstrap data set. So in this techniques, we are easily estimate a model uncertainty, and it involve creating a multiple samples from a single data set by randomly selecting element with replacement. Okay. In that, the same data points can be chosen a multiple times in this process. For the same example is given, from the data sets of 100 points, a new sample of 100 can be created. It's allowing a duplicate also. So in the bootstrap sampling is usually for estimating a model accuracy, particularly with the classifier like decision tree classifiers. The same, the boots base model training. So what we are given in the base model? So for each bootstrap sample, we train a base model independently. So on that, the subset of data, these weak models are trained in parallel to increase computational efficiency and reduce time consumptions. So here we are using a different base learners, that is a different ML model we are using here to bring a variety of robustness. So prediction aggregations. To make a prediction on testing data, it's combined the prediction of all base model. For classification task, it can include a majority voting or weighted majority, while for regressions, it involves averaging the predictions. So everything which is discussed in that diagram itself. Okay, the same thing, see here. So different subset which is given in a base model. So what is the base model we are discussed? Decision tree. So in the decision tree here, in each model, each subset is trained with the base model, and their predictions, they have some prediction will be there. By averaging these predictions, by using a regression method or classification method also. Vote by using a classification method, we are using a voting. So from this both we can able to solve the classification as well as regression. So we can able to get a accurate prediction. Okay. So now let us move on the next topic as boosting. So boosting means it's create a strong learner from the multiple weak learner. So boosting refer to the process of creating a strong learner from the collection of a weak learner. Same. So here the strong learner from the collection of weak learner. So boosting we all know, no? So we need energy. So how we are going to get an energy? So we are getting how we are going to be stronger. So by collecting all the weak learner, it automatically going to get a very strong. Okay. So a weak learner perform only slightly better than the random process. Slightly better than the random guessing on the training data. So the boosting work is giving more important to misclassified data. So here it's a misclassified instances there. Misclassified data is a forcing a future model to focus on difficult cases. A final prediction is determined by aggregating the prediction of all the weak learner. So with a higher emphasis is placed on those that demonstrate a superior performance. The same thing. So what are the prediction, what are the results which come under the weak learner? It all combined together and we are getting a final result. Okay, so in the training set. So the first subset, so there's a, we are splitted the number of subsets are there. So in a training data, we have given in a data, we are going to be trained. So in that, it take classify number of subset. So from the first subset, it going to be start training. So in that, it performs some weak results, weak learner. So from that weak learner, there is some prediction will be there, some output will be going to be get. So by using the testing, it get a false prediction. And the same, what is the result which we get from the weak learner, that is given to the next subset. Next subset, and from that it is going to given. So this is the first result which we get from the first learner. So that result is passed to the next learner. So from that it is going to get the next result. So like that, we are going to combine the false predictions of each weak learner. We are getting a overall prediction. Okay, so like that, if we have n number of subset, so we are getting a number of predictions. So from that false predictions, we are getting a overall prediction. Okay. So this is the concept of boosting. So the next type is the type of boosting algorithm. There are two popular boosting algorithms there. The first one is called as an adaptive boosting and second one is a gradient boosting. Okay. So in that, both methods, why we are using these two type of boosting, and so by using these two method, we have to improve our accuracy by learning from previous mistake. That's that diagram will represent, no? So what the result from the weak learner, from that weak learner, the next results, so it is going to be changed from that output, we are going to change from the next weak learner. So like the same process. Both method, it is used to improve the accuracy by learning from the previous mistakes. But they work a slightly different way. Okay. From the first type of boosting is AdaBoost boost. It's an adaptive boosting. AdaBoosting is one of the earliest and most popular boosting algorithm. It assigns a weight to training instance, weights to train the instance, and adjusts these weight based on the performance of the weak learner. So if we are getting one result from the weak learner, so we wanted to focus what is the outcome of that weak learner. So here it is a drawback. So what we are going to do? So what is the result from the weak learner? So from that we are going to give some weight and make a good performance for the weak learner. And misclassified data will get a higher weight. The future learner focuses more on these difficult spaces. The final prediction is done by using a weighted majority vote only. Okay. So the last one is the weighted a majority vote. Okay. The final prediction is determined by aggregating the prediction of all the weak learner. So through the weighted majority vote. Okay. So here some examples, we can able to see the real-time example also. In spam email detection, so the email is wrongly classified as a not spam, argue more importance for that particular. So we all know which is a spam or not spam. So but it is a some emails are wrongly classified, this is a not spam are given us, we are going to give more importance for that. The next model focus more on those emails, improving the spam detection. Okay. So the next one is gradient boosting. So here we are going to give a different training sets are there. So wait, we can see after that. So gradient boosting is widely used boosting algorithm. It's a sequentially where each models try to correct the error of the previous model. Okay, previous one. So gradient boosting is nothing but it's built a model sequentially where each new model it's tried to correct the error of the previous one. So it uses the decision tree. It uses a decision tree and optimize a loss function like mean squared error. And it is used for a gradient descent to minimize the error. So this method is very powerful as well and widely used in industries. Okay. So example we can take like companies like Amazon and Netflix. So they are using a gradient boosting method to improve their recommendation system. They are suggesting a product or movie is based on the user behavior. So at last the conclusion part. So ensemble learning, it's a combine multiple model for a better performance. Here there are three types is there, bagging, boosting and stacking is there. But now we are just saw the lecture in bagging and boosting. So bagging will reduce the variance and boosting it's reduce bias and focus on that mistake. These techniques are widely used in real world AI applications. So thank you. So in the next slide session, we will continue with stacking as well as unsupervised learning techniques. Thank you.